Hello ROS developers, and welcome to the second video of this series of videos about learning how to use MoveIt. And specifically in this project, in this series of videos, we are going to learn how to use MoveIt with Sawyer the robot created by Rethink Robotics. So we are going to apply MoveIt to that specific robot. And in this video, in the second of the series, we are going to learn how to create the configuration package of MoveIt for Sawyer. Okay, so that's the goal of this video. On the next video, we are going to see how to use that configuration package to actually move the robot. So now we are going to start with creating this configuration file. But before, in case that you are interested in making robots manipulate objects, I really recommend you that you visit our academy, Robotic Academy, where we teach about ROS, how to do things with ROS. And specifically here today, I would recommend you the ROS Manipulation in 5 days, which is a course that deals with all the issues, all the things that you need to learn in order to make a robot grasp things. So we teach how to use the MoveIt package, how to configure, perform motion planning programmatically, how to add perception to detect obstacles or where the objects are, and how to finally do the grasping of the objects. So really have a look. We use 3 different robots to teach you all those concepts. So have a look if you are interested to go faster and deeper. Okay, now let's go to what is interesting for us. So the first thing that we are going to do is to go to the ROS Development Studio and launch the simulation of Sawyer. Remember that we have created this simulation package on the previous video, on the video number 1. So go here, open the project, and wait for some seconds to open it. Remember that if you don't have this simulation created, I'm going to put a link beneath this video so you can watch the previous one of the series where we teach how to create that package, okay? So you can follow us. Great, so now we have the Sawyer simulation open. Let's go to Tools and open the IDE. We have to do a couple of modifications in order to set the gripper, to activate the gripper into the simulation and into the URDF for gazebo. So for that, let's go for the simulation workspace and then source. Here we have to go first to the Sawyer robot and modify the URDF description. So here Sawyer robot, Sawyer description, here URDF, and open the Sawyer URDF chakra. So if you open that file, you are going to see that, let me put it a little bit bigger so you can see better, that here the electric gripper is not selected and neither gazebo. So let's put those 2 values to true. Okay, one to gazebo and another one for the electric gripper. There it is, and save it. Then finally, we are going to use a specific launch file. It's not the one that we used on the previous simulation on the previous video. So that's why we need to also to modify one of the launch files here. So go to Sawyer simulator and then Sawyer gazebo launch file, and we are going to use this Sawyer wall.launch in the next videos and in the next exercises. So open that one, Sawyer wall, and then here where it says electric gripper, it says false, indicate true again. Okay, and save it. Control S saves, or file here, save, whatever. So I press always Control S. And then now let's test it, this simulation. So go to Simulation, select Launch File, and here let's select this Sawyer wall launch file that we just modified. And let's see how it appears here, the simulation with the gripper. So we can make use of the full robot in this series of videos, not just the arm. That is also interesting, but I think it's more interesting to grasp things. Yes, probably you agree with me. And here it is, the robot loaded. We have seen the gripper being constructed here in front of our faces, but basically we have the robot here. Yeah, it's kind of in the initial position, it's kind of colliding against itself. So, but probably this is not detected as a collision. So let's move a little bit the robot in order to see that everything is correct. So let's send a command, open a shell here on the tools, and let's send a command to this joint here. This is joint 0, this is joint 1. So let's go and send a command to the topic of joint 1 in order to move it and move the whole arm out of its own body and see if everything is correct, of course. So for that, if you do a topic list, so if you do, let me make it bigger. So if you do a ROS topic list, we should see the controllers being loaded so that they provide those command topics. Okay, there are different types of controllers for Sawyer. Here the velocity one and the position and also the effort are here. The one that we are interested here is the position controller for joint J1, this one. So this is the topic that we have to use. So let's copy this topic, Control-C copy, and then let's publish a value in this ROS topic pub -1 only once to that topic. Let's publish a command to move the joint there. And then if you do double tap, then it will autocomplete the type of message and even the data. So the data is just the angle, the position in radian that we want for that joint. Let me put 1 radian and let's see how the robot moves. There it is. So we can see here that the whole robot is complete. Okay, so this is for the simulation. Okay, just wanted to show you that we have everything working and ready for the simulation of the robot. We'll use this simulation in the next videos. Today we are not going to use it because what we want is to configure the MoveIt package. And for that, we need to launch the MoveIt Setup Assistant. So let's do it. For that, the command is ROS run MoveIt Setup Assistant, and then MoveIt Setup Assistant again. So if you launch it, then it will launch this magnificent program that allows us to configure any robot that has an arm to plan and to avoid obstacles, etc. This is amazing package. Thank you very much to all the creators that have created the MoveIt and all the tools that come with it. Okay, so then this MoveIt Setup Assistant, it opens a new window where in the graphical tools area. So we have to go to tools and press here graphical tools, and we should see here we should see here the window of the Setup Assistant, and here it is. So let's put it a little bit bigger so we can make use of the space that we have. Great. And then if I come here, I do double click on the title, the whole space. Okay, so now let's go create a new MoveIt configuration package. That's the option. And for that, we have to provide the URDF that we modified some minutes ago. So let's do a browse and go to where this file is. So user, simulation workspace, source, and Sawyer robot, Sawyer description, and URDF. And here we have the Sawyer URDF Chacro file that we have modified. Open it and then load files here. So now the MoveIt Setup Assistant, it's loading the MoveIt, the Sawyer URDF model in order to figure out which shape it has. Okay, so and that what is represented here is what the MoveIt Setup Assistant believes that the Sawyer robot is. So bear in mind that this is nothing related to the simulation. Okay, we can close the simulation also if we want, but so this is what the MoveIt Setup Assistant believes the robot is based on the Chacro file. Okay, so and then we see that it's correct. I mean, is the structure that we want. Okay, let's go. First step for configuring this is go to self collisions and generate the collision matrix. And we are going to take the default one. Just now, this is okay, good enough. Maybe, I don't know, but maybe in future videos we'll have a look at this in a deeper detail. Now, virtual joints we are not going to use for now. Also, in future videos we are going to see this. Then planning groups. Planning groups, we need to create a group that defines a kinematic chain that we want to plan, to use the planner to generate the trajectories. So for each, imagine that we have several arms. So for each arm, we'll have a group. In this case, because we only have an arm, we only are going to create a group for the arm. So let's call this group as the right arm. And then select a kinematic solver. That it's, let's select the KDL, kinematics plugin. Maybe in other videos we'll see the other plugins. And then we are going to leave the current values for those parameters. Now, we have to add the joints here on the option. This is to indicate which joints of the URDF are the ones that compose the arm. So in this case, we start with right J0. And let's see, right J1 here, right J2, J3, J4. And as you can see, when I'm selecting this, each joint, it is becoming red here in the model. So now I am checking this one here, the whole model of the J4. If I go, for example, to J2, you see that it has selected this joint here. Okay, so then you can see if what you are selecting corresponds to the real thing of the model. And instead of opening the whole URDF and following, that it's also interesting to do, but okay, so now we go fast. So J5, that is the one here. So select that there, and then J6 that we have there. And now we have all the joints that correspond to the arm. Okay, let's save it. Now we are going to create an extra group that is for the gripper. So let's call it here the right gripper. This is necessary in order to define an end effector later. Because it's a gripper, we don't need any kinematic solver because it doesn't need to be planned, but we need to indicate which joints are. And for this is the right hand. And then there is here the right electric gripper base joint and also the right wrist. Okay, so let's save it. And that's it, our set of groups. Then robot poses. Robot poses are poses, predefined poses that we may want the robot to have. So you can define here whichever the pose that you want. We are going to define here one just for testing at a pose, just to see, let me call it testing. Testing pose. It's just a pose for testing that everything is working. And then it affects just the right arm group. Then for this is just a stupid pose that ensures us that the robot has moved or can move from from its original position. So you play with the joints, try to move all the joints from just to check that everything is working. Okay, so if the robot is able to reach that pose, then it means that it's working. So if I move back, we can see how the pose is getting. Okay, so let me add also the 5 like this, and then the 6 like that. Okay, let's save it. Just whatever the pose, it doesn't matter. End effectors. Let's define the end effector. Add an end effector here, and let's call the gripper. And it's the end effector group. It's the right gripper that we have just defined before. And parent link it's the part of the arm that connects to this, and this case is the right J6, I think, yes. And then finally the parent group is the group, another group that connects to that one and is the right arm, of course. Then save it and we got it. Passive joints we are not going to have, and then author information, here it is mandatory, so here you put just your name and your email. This is mandatory. Okay, but you can put whatever. It's just checking that you have filled it with some values. Okay, so now let's go to configuration files and select a place where to save it. For that, browse, and let's put this. If you go to user, you see that we have different packages, and this configuration package is for moving the robot, the Sawyer robot. It doesn't matter if it is the simulated one or the real one. Then because of that, this is a general package for the robot. Then it doesn't have to go into the simulation workspace, but on the Catkin workspace. The Catkin workspace is the space, and then source is the space where to put all the code that it's independent to be run into the real robot or the simulation. Okay, so here you create a directory that I have already created here on the, well, I was doing tests, so just create it here with this option. Okay, so I have already created, and once you have created, just select it and then choose. Finally, get the generate package, press here. And it says that we don't have virtual joints, that's okay now. And in my case, it's saying that I have to overwrite the previous directory, and I would say, okay, in your case, that message would not appear because it's the first time. I was preparing all this video and then I forgot to delete everything, the whole directory. Well, anyway, so this is configuration package success. So let's exit the setup assistant. Great. So we have it. So now let's test it. Let's test this package, and let me put it here. Yeah. So what happened now? So what happened is that this MoveIt setup assistant has created, let me close here simulations and go to the Catkin workspace. He has created this package here. It's a ROS package, Sawyer MoveIt config. As you can see, is this here. So it has some launch files for launching the MoveIt in different configurations. And the one that we are going to launch now is this demo launch. Okay, so let's go and launch it and see if everything is working. So ROS launch, Sawyer MoveIt config, and then the demo package. Okay, so launch it, and then here on the graphical tools window that I didn't close, it should appear again something related to MoveIt that allow us to control the robot using MoveIt once it loads everything. And this is the control screen that we are going to use for controlling the robot with MoveIt. Basically a set of plugins for RBIS. And there it is. Great. So it looks like everything went okay. One of the things is that at present at the ROS Development Studio, some windows, they do appear like this in the middle of everywhere, and there is no way of moving it. So for that, we have a command that I'm going to share with you. So open Tools and the shell, and then there is a command that we are going to use issue on this shell for centering the window. So this command, it's a strange command, so you will have to pause the video maybe and paste it correctly. Copy correctly, sorry, because it is very, very strange command. It's based on an utility in the that Linux provides for this, and it's based also on it depends on the desktop that you have in your system. So here it is, the command is this one, so you can pause this and now uncopy. Okay, so I'm going to issue the command, and you will see that the window will set in a different position. Right, we got it. So now let's go here and then also do a double click on the blue thing so everything is centered. Great. And here we have the you can see the robot and also the end effector that contains, and it's a visualization that we can use for moving the end effector and making the planner put the end effector wherever we want. Okay, so in order to test if it's working, go to Planning tab, and then here in Select Goal State, let's select our testing pose, and then Update. So you're going to see that something happens here in this window. Wait, let me move it a little bit on top here. Yes, so we can see better, and then Update. Okay, so what can you see here? So this is something, characteristics of MoveIt. So what we can see is the first in the real color, but shade, with a little bit of shade, is the position that MoveIt believes that the robot is at present. Okay, so it believes that this is in this position. And then in orange, we have the goal position that we want. So we say, hey, please update the goal state. So we can see those two differences, where we are and where we want to go. Then for that, let's press the button here, Plan, to see if the planner is able to find a plan, a movement of the joints that moves from current position, from a start state to the goal state. And then as we can see, it has been able to achieve, and now it is showing us how would this plan be if executed. Okay, so that is showing it, and then so it's a little bit slow because it takes a lot of resources, but anyway, showing how the joints would move. So if you play the execute here, then it will actually make the move. So it's doing the move. But remember, at this point, it's only making this move inside this application that we have here, not in the simulation, okay? We still haven't connected this to the simulation, and we'll learn how to do this on the next video. So far, what we have learned is how to configure this to make able to move Sawyer with MoveIt, and we have tested that it works. So basically, that's it. That's it for today. So remember that next week we'll have another video that will be about how to integrate this with this simulation. So those plans that are being executed here inside MoveIt are going to actually be transferred to the simulated robot. Or real robot. If you have the chance to have a Sawyer, you can do exactly the same. So just point the ROS core to your real robot, and that's it. Okay, thank you very much. I hope that you enjoyed, that you understood this. In case that you have questions related to this video, don't hesitate to put it beneath the video. And please subscribe to our channel. We are posting a new video about ROS, how to do things, every day. So subscribe to the channel and press the bell so you will be notified. Thank you very much. This is all for today. See you next week.